Hi everyone, this is going to be a video tutorial on how to do a chi-square test of association in SPSS. Okay, so as usual we're going to be using the tutorial data found here. So this is part 3 of tutorial 8, and we've been given this table where we have two variables. We've got essentially rugby and AFL is one variable, which is our football code, and we have boot size from 9 to 14. This gives us 6 columns and 2 rows. This data here is our frequency data, and we're trying to see if there is an association between football codes and boot size. So the first thing we're going to do is set this up in Excel. Now when we do a chi-square test of association in SPSS, it can be a little tedious because literally what you need to do is list out every frequency that you have in your table. So for example, if we look at rugby and we look at a boot size of 9, well, we know that we have a value of 6. So what that actually means is that we need to write rugby 6 times. So 1 per cell in Excel. And we have to put 9 6 times. And you can see that I've tried to partition it, each of the boot sizes, using these colored brackets. So to give you another example, let's move across. We're going to look at rugby again with a boot size of 10. And so we have a frequency value of 10. And so we need to put 10 in 10 times. Same with rugby at a boot size of 11, where we have 12. So if I highlight all of these values that have 11 in them, and we go down here, we can see that the count is 12. So we've got 12 who play rugby with a boot size of 11. So on and so forth. We've got the 12s, boot size of 12s, we've got the boot size of 13s and 14s. And then in the same column, we would have the AFL as well, the boot size column, second column, and football code in the first column. Now, it's very important that you take extra care when you put this together, because one missed value, one error, will upset your entire data, and SPSS will spit out the wrong output. So, in the first column, we've got football code, we've got rugby and AFL. In the second column, we just have the boot sizes and how many there are. Now, what you want to do is you want to copy all of this and pop it into SPSS. Now, because it is a bit fidgety, I have pre-prepared this. So if I just go into my SPSS, we can see that the data has been pre-prepared. Okay, this is exactly the same as what we saw in the Excel spreadsheet. And so we have the football code as the first column and the boot size as the second column. We need to check our variable view tab and make sure we've named it properly with a string. We have rugby or AFL, and these are just letters, so we would use string type. And the measure is nominal. With the boot size, we use boot sizes, which is numeric data. So the type is going to be numeric, and that is also on a nominal measure. Go back to data view, and to do a chi-square test of association, we need to go to Analyze, Descriptive Statistics, and Crosstabs. Now we click Crosstabs, and here we want to put football code into our rows box and boot size into our columns box. We then have a few other buttons that we can click, and they give us a few extra options. So the first button we're going to click is the statistics one, and we're just going to select chi-square because we're doing a chi-square test. Now click continue. Then we're going to go cells, and it already has observed frequencies checked. We want to find the expected frequencies. So click expected and then click continue. We go to format, I'm going to choose descending order because I want to see the rugby category first. So I'll click descending. Now I'll click OK. If I expand this out, we can see that we have a sample size of 100 here. And we've also got this table, our cross tabulation. And we have the counts, and the counts correspond to our observed frequencies. So we've seen this before, 6, 10, 12, 10, 6, and 5. And 8, 14, 8, 8, 7, and 6. So the first part is for rugby, and the second half is the AFL. What's really neat is that it calculates our expected counts as well, expected frequencies or expected values. They mean the same thing, so 6.9, 11.8, 9.8, 8.8, 6.4, 5.4. And then we also does that for the AFL as well, so 7.1, 12.2, so on and so forth, and it also gives us the total when we add the observed and expected frequencies together. We also get the chi-square value, and this is the calculated chi-square value, and of course we would compare that to the critical chi-square value, and we would find a p-value as well. SPSS gives us the p-value, which is 0.835. That is greater than alpha of 0.05. Therefore, we would accept the null hypothesis, and we would say the distribution of boot sizes in football players was not related to the football code played. And then we'd provide our statistical evidence. Now, to check that we've done this correctly, I have previously done this by hand. So if we have a look at our expected frequencies, well, we can see that they add up. Our rugby expected count for boot size of 9 is 6.86 when calculated by hand, and it's 6.9. So it all adds up, and then we can calculate the individual chi-square value, which is 2.103. And that again adds up as well. When it comes to degrees of freedom, we notice that the degrees of freedom is number of rows minus 1 multiplied by the number of columns minus 1. So we have 2 minus 1 because our 2 rows were simply our rugby and AFL. And then we have 6 columns because we've got 9, 10, 11, 12, 13, 14. And so our degrees of freedom is 5, and this is what SPSS has told us as well. What's really important is this little note here. It tells us that 0 cells have expected count less than 5. The minimum expected count is 5.39. That's all fine and dandy because our one and only assumption that we have for a chi-square test of association is that our expected frequencies need to be greater than or equal to 5. Okay, we don't have anything that's less than that, so it's all good. So that's how you do a chi-square test of association in SPSS. I hope that will help you in completing your assignments for biostats.